Okay, so here we've created a similar problem to help you solve another problem that we're looking at in class, but still this problem does stand on its own. The idea is that we can use the Pythagorean triplets, which are right triangles where the legs and the hypotenuse are all whole numbers, to quickly work our way through this question right here. So we can use these triplets to work through and solve this question. So let's look at the question and we'll see how to deal with it. It says in the accompanying figure, the quadrilateral ABCD, so as soon as you see those letters, it's a good idea to go through it, A, B, C, and D, to see what they're talking about. So the quadrilateral here just follows those lines, A to B, B to C, C to D, and then D to A. And that's the quadrilateral we're looking at here. And they tell us which lines are perpendicular to which, right? DA, this line right here means perpendicular, is perpendicular to AB, so you see that right angle right here. DA is perpendicular to AB, and DB is perpendicular to BC. That's this right angle right here. And AD equals 8, AB equals 6, and CD equals 26. What they're trying to help you realize is that this quadrilateral is the sum of the areas of the two triangles that make up the quadrilateral, right? So we have these two triangles. If we can find the areas of these two triangles and add them up, we'll know the full area of the whole shape. So let's do that. Well, here in the smaller triangle, we have what? Well, we have 6, change pens here, is the base, times 8, so 6 times 8, and then divided by 2. If we figure this out, we can think, oh, well, that's equal to 6 times 4, right, just half the 8, and that equals 24. So the area of the smaller triangle is 24. And we're almost done. Smaller triangle is 24 square inches or square units. Now, if we find the hypotenuse, which we can quickly do, right, the 3, 4, 5 triplet here is being represented. We have our 6, 8, and 10. It's the doubling of each component of the 3, 4, 5. You can verify that with the Pythagorean theorem, or use Pythagorean theorem to solve the hypotenuse, but I'll leave that to you. If you set it up, you would get 6 squared plus 8 squared equals c squared, and then you realize that c must equal 10. And what's useful though is that this equals the base of the new triangle. And in fact, we're given another triplet, one that's not as easy to recognize here. It's a multiple of the 5, 12, 13. Now the 5, 12, 13, if we double everything like before, times 2, we get 10, 24, and 26. So that means, and you can verify this with the Pythagorean theorem again, that this should equal, well, 24, right? And just like before, we could set it up with the Pythagorean theorem. Over here, we could say 10 squared plus b squared equals 26 squared, and if you work through it here, you realize that b has to equal 24. So now we can find the area of the larger triangle. So we get what? Well, 10 times 24 divided by 2. And again, I just think of that's equal to 10 times 12, which equals 120. This is equal to the area of the larger triangle. Now add them together and we get the area of the quadrilateral, right? So we add up 24 and 120 and we're done. So 24 plus 120, that equals the area of quadrilateral ABCD. We can just write the letters out, A, B, C, D. And that's it. All right, hope that helped.